Thanks. Hey everyone, I'm Hannah. I'm with the Washington Department of Ecology's Applied Coastal Research and Engineering team. I'm going to talk a little bit about shoreline change analysis we did in the Cape Alava area. Next slide, please. Quickly, I'll talk about location, background, methods, results, and then spoiler alert, I'll offer up some nature-based solutions because we did find a little bit of erosion pattern there. And the slides are coming through like a little funky, so we'll see how it goes, but we can move on to the next slide for now. So this map is showing the northwest corner of Washington. That yellow box is showing the area on the Olympic coastline that we focused on. Next slide. And yeah, if we zoom in there, you can see the thick yellow line is delineating what we're actually seeing, where we were actually doing our analysis. We started off with focusing on the Ozette Reservation there, but decided to expand north and south into the Olympic National Park to get a little bit more context. That includes some campgrounds and recreation areas. Next slide. This photo is showing that Ozette Reservation area. So for anyone unfamiliar, it's the site of a massive landslide that covered an ancient tribal village estimated to be in the late 1500s. And so as a part of a larger project for the Makah Tribe, we did some erosion or coastline change analysis here following concerns of erosion that might be threatening cultural or natural resources in the area. Next slide, please. Typically, if you saw Amanda's talk before, we lug in a bunch of heavy equipment. We bring our boat in to do these kinds of shoreline change analyses. This site is pretty remote. It's primarily accessed by trail through the Olympic National Park. And the accessing by boat kind of poses some navigational purpose challenges. So we chose to use existing aerial imagery between 1977 and 2019. Next slide, please. And from that aerial imagery, we delineated a series of coastal features. So this slide, the dotted line in the center is showing where we might digitize a vegetation line. This is from 2015 NAPE imagery. Next slide, please. And then we can look at a subsequent year of imagery and digitize that same feature. So the solid line is showing where we might digitize that 2019 vegetation line. And next slide, please. So I'm going to zoom into this little area of erosion down in the bottom. And in this case, when we measure the distance between the 2015 vegetation line dotted line and 2019 vegetation line solid line, it's about 5 meters, or that comes out to be about 1.25 meters per year. I also just want to point out this 2019 imagery is really hard to see. I wouldn't be surprised if you're shocked that we can get a vegetation line out of this. I chose to include this photo in particular because it's pretty indicative of what we run into when we're using existing aerial imagery. Especially in this area, there's a lot of vegetation, there's a lot of shadows to deal with. Next slide, please. We digitized 3 different features, so I just showed you an example of the vegetation line, but in actuality, it was really hard to see the vegetation line in this area, partly because it was covered by vegetation. So we focused a lot on the shoreline for this study. And we also digitized something that we call the seaward edge of the sand wedge. It was just the interface between the upper sandy beach and the lower rocky terrace. Next slide. So we collected change rates between each subsequent year of imagery that we had for each feature, wherever we could kind of discern that feature, and then took many cross-shore transects and averaged them. For this presentation, I'm going to focus on the shoreline change between 2009 and 2019. Next slide. All right, there's kind of a lot going on this figure. I'll first direct your attention down into the bottom right-hand corner. That's just a zoom in on our 10-meter space transects. And so these are transects where we have average shoreline change rates for. Now the bar graph to the left is showing 1 bar for each one of those 10-meter space transects. So at the top is in the north of our study area, the bottom is in the south of our study area. And the blue bars going to the left are accretion, red bars going to the right are erosion. And the big thing that we're seeing here is that there's a lot of red bars going to the left or right, sorry, showing erosion. And that includes the north and south Ozette River camping areas. That includes areas along the Pacific Northwest National Scenic Trail, Wedding Rocks areas, and a lot of red in that Ozette Reservation. Next slide, please. So to make a little bit more sense of this, we did what's called a cluster analysis, where we basically were grouping together these 10-meter space transects into like groups, transects that were showing similar kind of rates. And we ended up with 28 total clusters. By contrast, we did the same kind of thing up in Makah Bay. It was the same along shore length. And we ended up with only 12 clusters. So right away, we know that this area has a lot of complexity compared to some of those sandier beaches. Next slide, please. So just to really summarize what we're seeing here, this graph is really similar to the one we just saw, but it's averages within those defined clusters where blue bars are accretion, red bars are erosion. We've seen that same pattern of a lot of red going on. In the northern reach, north of the Ozette Reservation, we were seeing an average of 1.25 meters per year of erosion. Then in the Ozette Reservation, we saw the highest erosion rate, average erosion rate of 1.27 meters per year. And then south of the Ozette Reservation, we saw a relatively lower erosion rate, 0.2 meters per year, but still maybe a little bit, something to watch for those camping areas and trails in the area. This slide has there's a gray arrow at the bottom pointing to cluster 46. That had an actually oddly high erosion rate for being in that southern area of 1.73 meters of erosion per year on average. And we did find that this is the location of a primitive camping area and also beach access. So there might be something going on with like more foot traffic contributing to the high erosion rate here. Next slide. Like I said, we couldn't see much going on at the vegetation line using the aerial imagery. So we cobbled together as many on-the-ground photos as we could, some of which from Ian Miller, who was doing some on-the-ground work here or in the area at the time. We also got a lot of great information out of Google Street View photos that folks uploaded while they were hiking, and then some oblique photos as well. And this Google Street View photo, where you can see kind of some erosion undercutting those tree branches or tree roots there, is from that same cluster 46 with the high erosion rate. Next slide, please. So these photos helped us, and along with the rates, kind of helped us to build our conceptual model, conceptual diagram of what we think is going on here. So basically, this is a high angle coastline. There are a lot of rocky bedrock kind of areas. There are scarps. And so as waves come in with high energy, they get reflected off of that high angle coastline, and then they bring sediment offshore with them as they're moving out. Next slide, please. Our group is particularly interested in nature-based solutions to things like this, to erosion that we're seeing. This photo on the left is from South Beach Campground area. That's a little bit south in the Olympic National Park. And the next talk, Heather's going to go a lot more into some work we're doing there. But I'm just bringing this up to say that when I talk about nature-based shore protection, it's basically that we're looking to nature, we're drawing from the things that we see there to kind of figure out erosion control ideas that work with nature, that use the beach processes that are naturally existing. In some cases, we enhance those beach processes in order to kind of use nature to our advantage rather than work against it. So there are a lot of considerations when we think about these kinds of erosion control ideas, including tidal and wave environment, geology. The big one here is access to the site. So our team actually had a lot of fun thinking about what it might look like to have volunteers come out and have kind of a community-based effort where we actually build some kind of structure by hand. Next slide, please. This is just one example of many different designs that could be implemented in this area. So this is our same kind of conceptual diagram, but we've now constructed a cobble and boulder berm. And so the same high energy waves come in, they hit the cobble or berm, and that energy gets dissipated. And so when it hits that high angle shoreline, we're actually getting some sediment accumulation rather than the sediment getting washed offshore. This particular diagram was adapted from the clam garden network. So this could be integrated with kind of the concept of building a clam garden. Next slide, please. We've actually seen this kind of rock berm before in our monitoring. This is down in North Cove, Washington. And I'll preface this with this is a very different environment. There's a lot more sediment available to build up here. But I just basically want to point out that in 2019, that picture on the left, there was a cobble berm constructed on the mid-beach. You can see that on the orange beach elevation profile. And then over the course of 2 years, by 2021, there was about 2.5 feet of sand accretion right in front of that rock berm. Next slide, please. So just to sum it all up, we did a historical coastline change analysis from aerial imagery. It revealed fairly widespread erosion trend. We really think there needs to be some more detailed monitoring if either the Ozette Reservation, the Makah Tribe, sorry, or national parks would want to help combat this erosion a little bit. But the good news is we think it can be treated with a nature-based approach. Next slide. Yeah, if nothing else, I hope you've gotten some beautiful pictures of, or seen some beautiful pictures of the Olympic coast, and I can take any questions.
Great, thank you very much, Hannah. Very interesting talk, and particularly of interest to me, since that's in my stomping ground. We have time for a couple of questions, a couple of short questions, and maybe while we're waiting for that, I will. Oh, you know, Kathy Troost has one, so I'll hold mine. Kathy, go ahead.
Hi, Hannah. Great talk. Thank you for that. The question I have is, did you go back any further, or how far back in time did you go? And were you able to look at whether or not there was erosion or accretion over the last, say, 100 years?
So we had photos available from Washington Department of Natural Resources back in the 60s. But like I said, there are just so many challenges using remote sensing data here. And so we kind of determined that the 1977 photo, 1997 photo were the only historical photos that we really felt confident in for that time period. And I will say, in viewing our rates, the long-term averages were quite a bit lower erosion rates. There were kind of more isolated areas of erosion in those historic photos. And then comparing that to the more recent rates, it does seem to be a lot higher than the historic. Yeah.
Okay, thank you. And we have actually one other, actually a couple of other questions. I'm not sure we'll have full time to get to them, but Bob Vittis is wondering whether this might have ramifications for, I'm sorry, I just missed that. Oh, for tsunami erosion impacts.
I think I can quickly answer that and say that's a different beast outside of my area of expertise. So the erosion that we're really tracking here is that kind of regular, maybe winter storm cycle, annual erosion. We haven't taken into consideration tsunami impacts. Yeah.
Great. And we have a couple other questions, and we'll just do one last one before we move on, which is any thoughts on using drones or lidar for structure for motion techniques out there?
Yeah, if you saw Amanda's talk earlier, that's our same group, and we love remote sensing. We actually did look into the DNR LiDAR portal for this, but the resolution of the airborne LiDAR was just too variable for us to feel confident. We did use it to help adjust some of our shoreline positions, and we can talk offline about that if you're interested in how we use that LiDAR, but we couldn't really use it to directly just say, let's grab a contour and compare the contours, because the resolution were just made it incomparable. That said, I think it would be a great site for some kind of more detailed mapping using drone LiDAR or structure for motion, something like that. The biggest thing to keep in mind, though, is that there are so many trees that that's kind of always going to be a challenge. Like it's always going to impact our ability to get really good coverage of that vegetation line. So yes, I think that would be great to add that context, but I do think we'd still see some challenge there.
Fantastic. Thank you very much.